Hello everyone. Welcome to today's session. Today we'll be talking about inheritance in object-oriented programming with relation to Python. Okay. So we have already seen what is object-oriented programming and what are the 8 methods, 8 core steps that we can learn to master object-oriented programming. So we have already seen what are classes and objects, what are attributes and method, and what is encapsulation, how encapsulation helps. Now, today we'll see what is inheritance. Okay. So let me proceed further. So let's start with the definition of inheritance. So, what is inheritance? Inheritance is a mechanism in object oriented programming where one class inherits child class, specifically, if we can say child class inherits the attributes and methods of parent class or the base class. Okay, so here is the simple syntax. So, I have written my base class, which is we can also call as parent class, and it has one method. Now I wrote child class and I inherited everything from the parent class. How I inherited? When I say class child, inside the child class, I say parent, I inherited everything from the parent class. Okay. So, what is the purpose of inheritance in object oriented programming? So, one is it helps code reusability. It helps you reuse common logic. So, there is common logic that is applicable to all the classes. So, I segregate that common logic, write it as base class or parent class, then reuse or inherit wherever in other class required. So, that is how it is useful. I can extend or override the behavior of a class. We'll see what is the example. What does this mean? And it helps us reduce the redundancy in the code also. So, for example, I have a parent class called vehicle, and inside the parent class, I can have my child class car or bike. But car or bike, even that is a vehicle. So, what are the common attributes of vehicle? It has wheels and engine. But car has four wheels and bike has two wheels. So, the general class, the base class will define, we inherit those attributes in our specific version of classes, such as car class or bike class. Now, what are the types of inheritance we have? So, we have 4 types of inheritance. So, we have single inheritance, multiple inheritance, multi level inheritance, and hybrid inheritance. Okay. So, we'll see one by one what of them. So, what is single inheritance? Single inheritance means when one child class inherits from the parent class. For example, I have a right class that is super or the main base class, but the mini right class inherits from the right class. So, that is how an example of one child class inherits from the parent class. So let's see example in the code how uh, single inheritance. What is single inheritance? So before that, let's go through these types of inheritances. So single inheritance means one child class inherits from the parent class. Multiple inheritance means a class inherits from more than one parent class. So, for example, I have a premium account class that inherits from two classes, bank account class and cashback class. So, this is called multiple inheritance. Then I have multi-level inheritance. So, in this, a class inherits from child class with again that child class inherit from another parent class. So this is called multi-level inheritance. Then we have hierarchical inheritance. So in hierarchical inheritance, we have multiple child classes inherits from the same parent class. So for example, I have a top right class that in the that is inherited by mini right, also prime right, or also auto right. So we have one more called hybrid inheritance. So this is a combination of each of these types of inheritances. This can be very complex. So Python internally uses method resolution order to resolve conflicts between the inheritances. Okay. So we'll see these 4 types of inheritance only with an example of ride sharing app, which we have been seeing from starting from the object oriented programming. So let's take a scenario. we have a generic ride class. So that has different uh, a ride type. So for example, it has mini ride, prime ride, and auto ride. Okay. So these all share common features but also have specific behaviors. So, for example, every ride has base fare, every ride has driver, every ride will have a customer. But each type may be different per kilometer, and based on the vehicle type and based on the luxury features also. So, the key takeaways that we can take is common logic is there. So that is base fare, driver, and customer, but to extend the common logic or to override the common logic behavior, we have to calculate specific fares for mini ride, which will be lower than the base fare, and prime ride, which will be higher than the base fare. And it promotes code reusability also, and promotes real world modeling also. Okay, so let's see a single inheritance example here. So I have a base class ride. Okay, so I have defined these methods underscore init. So we have already seen these. And self, it personalizes our data. And now I have two attributes, customer name and kilometer distance. So these are general attributes that are applicable across all any types of rides, whether you take mini ride or a prime ride, auto ride. So mm, these are general attributes that are applicable to all of them. So we define this as common logic. So this is our base class or parent class. Now in our parent class, I have these two attributes. I have one method. Okay. So I wrote a child class called mini ride. So let's say in my app, I selected mini ride and I'm inheriting all the attributes from the parent class like customer name, distance, calculate for everything. So how I'm able to do? I just after the mini ride, I write the base class name here. So that way I'm able to inherit all the attributes and methods of my base class. So this is a single level inheritance. So again, I wrote one more class and I inherited from the base class. Okay. So here we can notice mini ride, my calculation fare, and in my base I'll see here in my base class, distance into 10 is my base fare. So whatever the distance will be into 10 is my base fare rate that I have set. But based on the user selection, that for example the user have selected a mini ride, so I would like to calculate based on that. So it would be into 8, and if I select prime ride, it would be into 15. So now I'm creating an object. So I say ride one. So user one is doing a ride one. So I'm calling mini ride. This is a child class. So, and the child class, you notice we don't have a name. We don't have customer name. So where does it get? Where how we are able to pass the customer name? Because we already inherited the base class, parent class, that is the ride. So that ride class has customer name and distance. So we are able to pass customer name and distance with mini ride also. So we are able to reuse the general logic here and extend the behavior. So the basic behavior of our base class is base rate is whatever the kilometer be into 10. Now you can notice when I execute my program, the kilometer into 8. So 10 into 8, it will become 80. So it has overridden my base rate, that is 10. So the base rate would have come 10 into 10, that would be 100. So if I have calculated based on my base rate, but since I used mini ride class, I overridden my existing behavior by using inheritance. So by using inheritance, I inherited the base class as well as I have overridden um, or extended the behavior of base class by specifically calling the mini ride and prime ride. So you can see we have calculated the shares accordingly. Now next we have multiple inheritance. So what is the meaning of multiple inheritance? A child class inherits from more than one parent class. Okay, so I have a child class that is base class 1, and I have another class base class 2. So I have two base classes, one is ride, one is discount. So when I'm inheriting, when I'm inheriting both the base classes into my child class, it is called multiple inheritance. This simple. So what's the use of multiple inheritance? So I have customer logic, customer separate, and discount logic separate here. So I'm able to inherit that and able to pass the values, the customer name and total distance in kilometers for prime, right? Based on that, I am able to calculate the fare. So how much the fare should be? 10 into 15, 150. But finally, it will come 140. Why 140? We are applying discount also. So what is the discount logic here? Discount is return 10. So minus 10 rupees off we are doing. So that is where we are doing a discount here. Okay. So this is multiple inheritance. Now next we have multi-level inheritance. So what is multi-level inheritance? So in multi-level inheritance, you can see um, one base class. Let's see an example of multi-level inheritance here. Okay, a class inherits from child class, which itself inherits from another class. Okay, so multiple level of inheritance we have here. So let me uh, scroll down here. Go back to multi-level inheritance. Oh, I have a vehicle class. This is my base class, the top hierarchy in my classes. Okay, so I have another class which inherit vehicle class. So this is my right class. This inherit vehicle class here. Okay, so this is first level of inheritance. And again, I have written electric right class, which again inherits a right class. So this is multi-level inheritance of the classes. Okay, so here, uh, so we have defined the logic uh, here, so that for my electric ride, based on the model and the based on the model and the distance, based on the distance, I'm calculating the fare. So 12 into 10, 120 is the base fare. And here I'm passing battery percentage. How much is the battery percentage and the customer name, all those things. Okay. So this is multi-level inheritance. So then we have hierarchical inheritance. So what is hierarchical inheritance? We have just one parent class. That one parent class has been inherited by multiple child classes. So for example, I have parent class called ride. So I have customer name, distance in kilometer, and then I have one child class called mini ride, then another child class called prime ride, then another child class called auto ride. So they all inherited my ride class. So this is my ride class. So mini ride inherited a ride class, prime ride inherited a ride class, and auto ride inherited child class. So this scenario, when it occurred, one parent class has been inherited by multiple child classes. This is called hierarchical inheritance. So I can call my object, I create my object by calling the classes. So when I run my program, customer Shah distance 10 kilometer, fare is 80. Customer Salim distance 10 kilometer, fare is 150. Customer Amina distance 10 kilometer, fare is 60. So this is how, based on the classes that we call, the objects that we create, our fare is calculated. So we are using the base class also. We are using the attributes and methods of base class also, and we are extended the behavior of the base class by defining its own logic inside each of them, that is mini, prime, and auto. Okay, so these are the advantages of inheritance. So what if we do not use inheritance? We have to write a lot of redundant code, and it's harder to update the logic across similar classes, because you have seen, right? So the base class, right, it remains everywhere. It remains same everywhere. So every time, why should I write that everywhere? I can just inherit that. I can just inherit that behavior. So in inheritance, you write once and reuse or extend everywhere. Okay. So here I have put down a mini exercise for you. Just you can execute this program and see yourself how inheritance works. So otherwise, it's you can refer the earlier programs that I have written. So here is a simple program for you to exercise or do a hands-on on inheritance. So far, what we have learned, just a quick recap. Inheritance we have learned. So what is inheritance? One child class inheriting from the parent class. So behaviors and attributes are inherited from the parent class. So there are different types of inheritances: single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, and hybrid inheritance. So what does inheritance do? It allows you it allows a class to reuse and extend another class. Single and multiple inheritances are supported in Python. It makes code modular. So this way, we are following a concept called "don't repeat yourself," dry concept, and it's easier to manage also. So that's it for today. We'll meet next time in another class. Thank you. Bye bye.